what needs to be considered with any kind of machining, regardless of the size of the parts, there's a lot of considerations that have to be made. With heavyweight parts, there's obviously some very obvious considerations. One is how you're going to clamp it, how you're going to put the part into the machine, and how you're going to support that part. So various parts like the M50 here, which can handle parts up to 1,600, almost 1,600 millimeters swing in diameter, and between 2 and 12 meters in length, the parts can get very heavy. So the ability to support the part becomes the most critical portion of it. During the dynamics of turning, there's a lot of forces that are exerted on the machine, so the machine has to be rigid enough, not just in the clamping areas, but the supports for the clamping, the slides, and also the base itself. So WFL manufactures all their machines with this in mind, and it's the force from the turning that they have to be able to keep the rigidity so the part can be manufactured in a most efficient, highest throughput rate. The highest throughput meaning you got to run your efficiency to the level of the fastest you can make that part reliable without defect. So that being said, you want to support these. You want to support the part in different matters. You got the headstock. The headstock is clamped on the part. That provides a support. Tailstock, steady rests, and in this case we have a weight reducer underneath the part. So one of the things which is most important to us is these parts, when they come to the machine, they represent a large amount of cost to the customer. And to handle this part and produce the part and make the end component so the customer can ship the part is of paramount concern to us. And that's why we have machines like the M150. Again, best quality. For large pieces, the best quality comes from knowing how to put the part in the machine, support the part, as I recently said. We have to take when you put it in a horizontal configuration like this, gravity is going to be the biggest culprit as far as movement of the part. Granted, temperature can move the part as well, and other aspects can move the part. So using our engineering, use a lot of time finite element method to determine exactly where the forces are going to go and how the parts can react when they're set in the machine, and also experience from our applications engineering, knowing how the machine reacts to heavy parts is very important. Machining, being able to machine with a rigid type envelope is extremely important as well, and also when you do other types of actions on the part, like deep hole boring and drilling and turning for profiles inside, you have to have rigidity in boring bars. You have to have capability to be able to load right angle heads, etc., different types of heads as well. And we have a prismatic type arrangement for that. And we also are able to deliver those tools in that prismatic arrangement. The boring bar is also carbon reinforced to give you maximum stability, because dimensional reliability is extremely important, especially when you're deep inside a part. So, and also when you're doing deep hole boring or turning, the coolant, high pressure coolant to make sure the chips are evacuated properly is also extremely important. As with any parts, large or small, measuring capabilities is very important, because the part does move, especially large ones, so the diameter might move, and you want to know where that diameter is, and you want to know how to compensate accordingly. Be it thermals that cause the diameter to move, or be it any other reason, you have to make sure you have a datum point, you know where your part is, and when you're finished, it's going to be to size. Also, milling details and slot ways, key slots, fir tree type applications on the part. So gears, etc., need to be measured, and those are more dynamic type measurements, because it's not just OD or ID. It's something that's pretty important. Another way is measuring the wall thickness of its ID compared to OD using ultrasonic measurement. Ultrasonic measurement is very good, and it's a technological advancement from WFL to measure wall thickness to determine concentricity, runout, from both ID and OD, etc.